So student, today we will start our new chapter, that is work and energy. So write down work. Chapter name is work and energy. Work and energy. So first of all you write down the definition. Work. Write down work is done. Work is done when force produces motion. When force produces motion. Next you write down work done by force. Work done by force depends on first magnitude of force, second distance through which a body move, distance through which, I will explain it. First you write distance through which body move. So work is done when force produces motion. What is the meaning of this? You draw this diagram. Suppose an object is kept here. It is kept on the surface. This is object. This is object. And you are applying a force at one end. And this is the surface. You need to draw it. Now, due to this force, if body displaces, means if body covers some distance, after some time, then its position changes. Now it's the final position. So here there is some displacement. So whenever you apply a force on any object and it creates, if that force creates, this is the object, you draw it. And so whenever you apply a force on any object, if it creates displacement, then we call it that body is in the state of some work is done by body, some work is done by external force, this force. So work is done whenever force produces motion. Here force produces motion. Body is in the state of what? Motion. And this work done depends on the magnitude of force. Magnitude means amount. Suppose I am applying a force of first 6 Newton. So this 6 is the magnitude value. If I again apply the force of 10 Newton, so again this 10 is the magnitude of the force, which is more, 6 or 10? 10 is more. So we can say the magnitude of force is more in case of second, that is F2 is greater than F1. You also make a note of this. Note down everything. Next topic, write down mathematically. Next again you write down mathematically. Write down mathematically. Work is the dot product of force and displacement. Work is the dot product of force and displacement. So you can write work is equal to dot product. This is dot and it is in the it is product. Dot product. Product means multiply. As we know, force is vector quantity, so put an arrow over force. This represent force vector. S represent displacement vector. And here work, W is work. It's not weight, it's work. And its unit is, it is a scalar quantity, so you write it is scalar quantity. Vector means both magnitude as well as direction, but scalar means only magnitude. Okay, so write down what is the unit of work. You see, SI unit of work, what it is joule. It is joule. Write down Joule, joule. And write down one more point, 1 joule. This 1 joule is equal to, force is Newton, so write down 1 Newton. And second is, this is displacement, and displacement unit is meter. So 1 joule is equal to 1 Newton meter. Okay, so 1 joule is 1 Newton meter. Again, you note one more point, CGS unit of work. CGS unit of work. So CGS unit of work is ERG. 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 And 1 ERG is how much? Write down 1 dyne centimeter. Write down here. 1 ERG is equal to 1 dyne into centimeter. Dyne is the CGS unit of force and centimeter is the CGS unit of displacement. What is dyne? Dyne is the CGS unit of force. Is the CGS unit of force. CGS unit of force is dyne. Write down. CGS unit of force is dyne. Okay. So work is, mathematically we can write it's a dot product. There are two products. One is cross product, another is dot product. That you will study in higher section. So little bit I will explain you the concept of dot product later. Okay. In this video only I will discuss this thing after some time. Now write down work done against gravity topic. Work done against gravity. In this you write down example. Write down example, work done against gravity. Work done work done in lifting a body work done in lifting a body against gravity is equal to weight of body multiplied by vertical height. Vertical height. Weight of body into vertical height is the work done in lifting a body. Write down one numerical on the basis of this topic. Calculate the work done. Calculate the work done in lifting 200 kg of water through a height of 6 meter. Through a height of 6 meter. Take G is equal to 10 meter per second square. Calculate the work done in lifting a 200 kg of water through a height of 6 meter. Work is equal to, so here weight is how much? The formula for work is work done against gravity. So it's what is the weight here? mg, we know it, okay, to a height of 6 meters. So you write work formula. This is work. Work is equal to weight into height. If you want to draw the diagram, draw it. This is an object. Its mass is m. It is given here. So weight is what? mg into, here it is height. So you write here height. So work is equal to mgh. So where work is, where gravity is acting in downward direction, that is mg. And you are lifting this mass to a height of 6 meters. So displacement is in opposite direction. Okay. So here m is given. How much m is given? 200. G is also given. It's 10. So right here 10 to height of 6. So here it is asked work done in lifting. Calculate the work done in lifting 200 kg of water. So suppose this is 200 kg of water. We are lifting. And we are lifting against gravity. So gravitational force is acting downward direction and displacement is in opposite direction. So we write here, you also write work done in lifting. Work done in lifting. So where we are applying a force? We are applying a force in upward direction to lift. Write down. F lift is the direction of F lift is toward the displacement. Force is also acting here in upward direction and displacement is also upward direction. That's why both are having same direction. This is the direction of lift. You are applying force in upward direction. That's why both are in same direction. That's why we'll get here plus sign, because force is of 3 types: positive, negative and 0. If the force and displacement and force both are having same direction, that time work is positive. That's why you will get work here. You calculate and tell me the answer. The unit of work is joule. You multiply it. Yes, it's 12,000 joule. 6 to the 12, 3 zeros, 0, 0, 0. This is the answer. Okay. In the same question, write one more. This is A. If in this question it is asked, suppose work done by gravitational force, that time you have to write here F gravitational into displacement, that is H. Here displacement is height, vertical height. Height is also the displacement. Height is the displacement. So here we have to find work done by gravitational force. That's why we have to take gravitational force only. Understood? When it is asked work done by frictional force, then you have to write here frictional force. When it is asked work done by applied force in place of gravitational force, suppose it is applied force, that time you have to take here applied force. Whatever it is given, whether it is gravitational force, work done by gravitational force, spring force, any force, we have to consider that force only. And gravitational force on an object is mg. Always remember. Okay, gravitational force here, in this case, gravitational force is mg. G is the gravity and it is acting in downward direction. So downward direction it is acting, gravitational force, and displacement is in opposite direction. So both are in opposite direction. Okay, gravitational force is acting in downward direction, displacement is in upward direction. So both are in opposite direction. That's why here it is negative. So write down. You will get here what? Negative work done. So you put negative sign here because the direction of force is acting in downward direction, that is mg, that is gravitational force, and displacement is in opposite direction. Both are in opposite direction. That's why we have to put here minus sign. You remember this point. Okay, so the answer is how much? What is the mass? 200 g, and height is how much? 6. So its answer is minus 12,000 joule. So work may be positive, negative, or 0. Whatever it is asked, whether it is gravitational force, that time you have to take what? What you have to take? Work done by gravitational force, you have to take gravitational force. Work done by spring force, you have to take spring force. Work done by applied force, you have to take applied force. In this way you have to solve the numericals. Next topic you write down. Calculate work done by, write down, work done by a force obliquely. Obliquely. What is the meaning of this? You draw a diagram, then you will get. This is the surface and this is the object. Draw it. This is the surface. And you are applying a force in inclined way. In this way you are applying the force. And here it is, displacement is toward this. So you notice one thing here. Force direction is this and displacement is this. So there is some angle between them. So you are not applying force simply in this way or in this way. You are applying a force at some angle. that angle is theta. Angle is called theta here. So write down here, theta is what? Angle between force and displacement. So this is obliquely force. This force is oblique in nature. It is having some angle with displacement. So write down theta is the angle between force and displacement. Force and displacement. Okay. So in this case the work is, write down, in this case the work is force, as we know the formula is force dot displacement. This is the dot. In physics there is two types of multiplication. One is cross and second is dot. That is 2 into 2, you know, 4, and 2 dot 2. 2 dot is also a product. But in physics there are we have to consider either dot product or cross product. We have to multiply, and both are not equal, both are different. That you will study in higher section. So work, you know, work is the dot product of force and displacement. Dot product. Okay, this is dot product. It is also called scalar product. You write down, this is dot product or scalar product. Scalar product. Okay, so the formula of dot product is, you just write the formula F S, and you have to multiply one term that is called cos theta. You have to multiply with this. This is trigonometrical term. Write down trigonometrical term. I will tell you, you will study everything about trigonometry in class 10th. Okay, but little bit I will give you the some hint. Suppose this is right angle triangle. Draw it. This is right angle triangle. This is the angle theta. Right angle means 90 degree. Now you know opposite of perpendicular, opposite of 90 degrees hypotenuse. So better you write here hypotenuse. Okay, now you have theta, this is a theta angle. So opposite of theta is perpendicular. Always remember this thing. Opposite of theta is perpendicular. So which one is perpendicular? If it is A, B, C, you tell me. Opposite of theta is perpendicular. So which one is perpendicular? Tell me. Opposite of theta, that is AB. So you write here, this is perpendicular and this is base. Now you know Pythagoras theorem. What is the Pythagoras theorem? H square is equal to P square plus B square. Okay, this you know. No need to write this, you know. Now if I find the value of ratio of base upon hypotenuse, that ratio will give the value of cos theta. Okay, it's a ratio of base upon hypotenuse in which triangle? Write down right angle triangle. You will learn everything about trigonometry in class 10th. Okay, just you remember, this is trigonometrical term and its value is, it's a ratio of two sides of a triangle, right angle triangle, that is base and hypotenuse. And you also note some formula, some value, that is cos, if the angle is 0 degree. If the angle is 0 degree, you make a table. Theta is what? Angle, just now I explained, this is angle. And here you write cos theta. Okay, and here you write values. In this way you have to make a table. Okay, so first write down, if theta is 0 degree, means force and displacement are in same direction. It means you have to write cos 0 degree. This is degree, you know, cos 0 degree. So this is 0 and degree small. Its value you have to remember, it's 1. Second, write down 30 degree. All this value you have to learn. Write down cos 30 degree, it's 0.86. Next, cos 45 degree, no need to remember 31 degree, 32 degree, 15 degree, only these are important, up to 10 also. So better you remember all this. Cos 45 degree, so you have to write here cos 45 is 0.70. Next you write down 60 degree, so in 60 degree write down cos 60 degrees, it's 0.5. And last 90 degree, cos 90 degree, it's 0. So make a table and remember all these values so that you can use in numericals. Okay, you can use in numericals. So when these are two important, when angle is 0 degree, when angle is 90 degree, and last you also write 180 degree. 6 number, it's 180 degree. So cos 180 degrees, it's -1. Okay, it's -1. These 6 are important, but main these 3 are, these are mains. You have to remember the cos 0 degree value. What is the meaning of cos 0 degree? Means draw it. Okay, we will discuss later. Okay, up to this you note down. Now write down types of work. Next topic, types of work. Types of work. First you write down positive work. Positive work. In this you draw a diagram. This is the surface and you are applying a force in this direction. And suppose displacement also takes place in the same direction as that of force. So here work is what? So here what you notice here, force, write down force and displacement. Force and displacement are in same direction. That is theta is how much? 0 degree. Write down theta is 0 degree. How? Because both lie in a same line. So theta is 0 degree. So in this case work is positive. Example you write down. The force of kick. First you draw, then you write. Draw this diagram. This is a ground surface. And draw a ball. This is a ball. Okay. And you are applying a force in this direction. You are kicking this football. This is football. This is football. You are applying a force on this football. So what is the direction of motion here? This is the direction of motion. So write in this, the force of kick. You are kicking this football, so the force of kick act in direction of motion, in direction of motion of ball, motion of ball. Okay, so here this is an example of positive work, because you are applying force in this direction and displacement also in same direction. That's why here work is positive. Next write down negative work. Negative work. In this you write, if force and displacement, force means F, displacement means S. if force and displacement, that is S, act in opposite direction, act in opposite direction. Okay, so you draw a diagram. This is the surface, this is a football, this is football. So direction of motion is, this is the write down, this is the direction of motion. Motion direction is toward right. And where friction force act? You tell me. Friction force always act at the contact surface. Draw it here. Here friction will act. This is direction of what? Frictional force. Write down, this is frictional force. So always remember, direction of frictional force is always opposite to the direction of motion. Direction of frictional force is always opposite to the direction of motion. So you see, force is acting toward left, that is frictional force is also a force, and motion is toward right, so displacement. So how much angle? It's 180 degree, and cos 180 is -1. So here work is what? Negative. Write down. You can write in this way, frictional force into displacement into cos 180 degree, and we know cos 180 degree is -1, so we'll get frictional force into displacement. The main thing is you have to put minus sign here. Okay, this is important. And in first case, that is positive work, in that case both are in same direction, so you can also add there force and displacement in same direction. That's why theta is 0 degree. So what is the work? Force into displacement into cos 0 degree. So work is force into displacement. Work done is equal to force into displacement. So here work is negative. Third one, you write down zero work. Zero work. Write down in this, when force and F means force and S means displacement. If force and displacement are perpendicular to each other, perpendicular to each other. Okay, if force and displacement are perpendicular to each other. So again you draw a diagram. Suppose this is Earth. Draw it. And around Earth there is an orbit where satellites revolve around the Earth. So this is the orbit where satellites can revolve. This is what? This is orbit where satellite can revolve. This is satellite, and this is the distance of satellite from the Earth's surface, that is h, and this is the direction of velocity. So this is the direction of displacement also, because velocity is rate of change of displacement. So you write here direction of displacement is s, and where is the gravitational force? It is toward the center of the Earth, it is acting. So you see here the angle between force and displacement is 90 degree. Here you draw this diagram and write here, write down here, force of gravity act right angle to the direction of motion, direction of motion of satellite, direction of motion of satellite. So here work, what we have to write? It's direction of motion of satellite. So write down work is equal to force, here gravitational force if we are considering. So work done by gravitational force is what? GF means gravitational force, GRF. Okay, gravitational force into displacement into cos. What is the angle between them is 90 degree. So cos 90 degree is 0. So better you write here directly 0. So always remember, work done by gravitational force while circular motion is 0 work done. So work done may be positive, negative as well as 0. So in this case work done is negative. You note down these points. So at last you write down some formulas, all the formulas of work. Write down formulas of work. First formula you write down, work is equal to m into g into h. Now according to question you have to use the formula. If mass is given, g is given, then h is given, that is displacement, then you have to use this formula. Second formula write down, work is equal to half into mass into final velocity square minus initial velocity. What is v here? Final velocity. What is u here? Initial velocity. Okay, third point you write down, and m is the mass. M is what? Mass. H is displacement, vertical displacement. So these two formulas. Third formula you write down, work is equal to weight into height, because mg is what? Mg is the weight. So write down third formula. According to given condition we have to use the formula, weight into height. Fourth formula you write down, work done is equal to change in kinetic energy. This I will discuss later. You just write down, this is change in what? This is change in kinetic energy. Kinetic energy. Next formula I write down, work formula. Work is equal to force into displacement into cos theta. And in theta there are three conditions you know. If theta is equal to 0 degree, work is positive. If theta is 90 degree, work is 0. If theta is 180 degree, work is negative. So what is theta here? Note down. Theta is the angle between what? Force and displacement. Write down. This is angle between force and displacement. Force and displacement. Last formula you write down in this chapter, work is equal to power into time. Work is equal to power into time. Now note down some numericals for practice. This will be the homework for you. Write down. Or you can comment also. Write down, if m is equal to 150 kg, initial velocity is equal to 10 meter per second, final velocity is equal to 5 meter per second, find work. Which formula you have to use? Formula number 2. Write down F2. Formula 2 you have to use. This is question number 1. Next write down question number 2. It is 150 kg. Question number 2. If weight is equal to 6 Newton, height is equal to 20 meter. Find work. So which formula you have to use? Again, tell me. Work is equal to weight into height. That is formula number 3. Formula number 3. F3. Formula 3. Next question, write down. Question number 3. If power is equal to 6000 watt, time is equal to 2 minutes. Which formula? And you have to find work. Then work is equal to power into time, but it is in watt, that's why you have to convert into SI unit, that is second. So you multiply here 60 second. Now you solve this question. Last formula, that is question formula number 6 you have to use. Question number 4, write down. If weight, I think this over. Next, write down. Find mass. Find mass if work is equal to 2500 joule, height is equal to 5 meter, and you have to find mass. Take G is equal to 9.8 meter per second square. Okay, so you try this for question also. Think which formula we have to use. And at last question, question number 5. Draw this diagram. Draw a surface. This is object, and you are applying a force. In this way you are applying a force, and the force is, it is given, force is 200 Newton. This is applied force, and you draw the diagram. This is displacement. This is the direction of displacement. If the angle is, suppose if the angle is 30 degree, you have to find work. You have to find work. So you have to use which formula? That is Fs cos theta. You have to find work done by applied force. Right down here. Work done by applied force. Okay. So these are the question which you have to answer me. That's all for it.